Thanks very much for the invite. We were really happy to be able to come and talk today about what's been quite a large project for us at swimming. So we thought we'd give you a bit of a case study analysis of a project called SPARTA that we've been involved in over the last little while. It's our race analysis system, but we're getting toward the end of development work on our latest version of this system. So this is what we use in competition at the major meets. So it's not what we use in training environments, but we're just going to explain through where we've come from with this and show you what we think is a more modern approach that will give us a lot of benefit. So SPARTA, an acronym, as you can see, the Swim Performance and Race Tactical Analysis. So it combines video footage that we capture at the pool, and it has a bespoke analysis software that the AIS have developed for us. And that's linked to the AMS, or what we call the AMS, which is the Fusion SPARTA-based platform. So by way of a bit of history, swimming was quite an early adopter of the SPARTA-based platform. We're into our 6th year of using it, and we use it and rely on it very heavily. So for many of the reasons that we've heard about today, so it's everything from athlete monitoring, injury management. We keep all of our pathways testing protocol information in there, physio, all of the different disciplines in our support teams. But one reasonably unique aspect of our SPARTA base is this race analysis system. So the bespoke software out of the AIS works in connection with SPARTA base, and then we've also introduced a machine learning module out of La Trobe University that Stu Morgan's developed for us. So all of those components work together to make our new system. At the moment, we're on what we call SPARTA version 1. The new system will be SPARTA version 2, which isn't very creative, but I'm not very creative. So basically what we've got now is the capture of race videos. So we have a camera on each lane of the pool, and we have a lot of human intervention. So we've got many people sitting beside the pool then, manually annotating that race video. So every time the swimmer takes a stroke, every breath the swimmer takes, when they turn, all of those things are manually inputted over that footage. And the output that we have at the moment is principally a PDF report that we fire off out of the SPARTA-based system, and it wraps up all of the different metrics that have been captured via that annotation process. That's served us quite well over the last several years, but we just saw the potential to do a few a little bit more cutting-edge things, and also we were missing a couple of opportunities with what the system could provide us. So we engaged with all of our partner organisations who contributed to the project, and I'll sort of run through those later. And we embarked upon the SPARTA 2 project. So on that note, this slide's really to demonstrate how we've come through various iterations of this race analysis system. So before I was even at swimming, we had a system, and I think Jess used to use it, called Green Eye. So it was our sort of first main attempt at this. So it did enable video analysis, again, manual annotation, and it just captured some fairly basic metrics about the race, split times of laps and that sort of thing. So that was stage 1. Then we, in conjunction with the AIS, developed SPARTA in its first iteration. Again, it brought together the video and the data. This time we captured a lot more metrics in terms of there was a lot more points of the race that we could capture to later analyse. But the problem with it, it takes about 16 people to operate. Then there's lots of equipment associated with this. So we need sort of 8 cameras, we need computers, we need all the peripherals, we need hard drives to transport the footage around the pool deck. And Jess is lugging this system all over the world to our major meets, so it's not an ideal setup for us. So we knew we could improve on even the actual hardware and the system design as part of this process. So with SPARTA 2, what we're expecting to see is not only a lot more granular data captured, more metrics, more meaningful metrics, but we're also expecting a bit of an explosion in the volume of data that we have available to us. And that's because under the new system, we're able to capture the entire swimming pool in one go, rather than focusing on one lane in the race. And at the moment, we've been growing with the amount that we've used the SPARTA system, but I would expect in 2020 and beyond, we'll see quite an explosion because of the automation that sits behind the system. So you can see there, I've just chosen the last couple of Olympic years. Back at London that year, we did about 2,000 races worth of analysis, and that was across 122 of our top-tier athletes. So all of that information's still available, and we still drag that information out of SmarterBase on a regular basis. So, for example, recently we've had a lot of use for that data with some of our university projects that we have underway. Then in 2016, that grew by quite a bit to just shy of 3,000 races, and we analysed quite a few more athletes also. So this is where we started to really get the engagement with the current SPARTA system. And then this year to date, we're at about 2,600 races, but across 253 athletes. So in a sort of more visual illustration of that, that's our breakup year by year. You can see the average number of races analysed per athlete, the number there is 14. But if you go up the tiers of our categorised athletes to our top tier athletes, we've got hundreds of races analysed for them, all of which sit within SmarterBase. And I'll show you how that looks in the system a little later on in the presentation. But that orange line, I think, post-Tokyo, will end up with a very sharp spike there. That's our goal. And that has lots of flow-on benefits for us, because then we can do a lot more meaningful research and analysis. We've got a lot more to play with, and we can also get a view of our competition for the first time.
So what you can see here, this is a screenshot of SPARTA 1 and what it looks like at the moment. So this is the software that I work with to analyse a race. And this is basically the field of view that you'll get. As the swimmer dives off the block, we actually zoom in a little bit. So you'll generally get one lane through the middle with a swimmer, and you may get one swimmer either side of them if you're lucky, depending on how zoomed out you are. Basically, you can see on the side, on the left there, they're the different annotations that we're putting in. So feet off the wall, the location of the swimmer in the pool, their breakout, which is when they surface from underwater, up onto the top of the water. Every stroke is annotated. If they take a half stroke, breath, kicks. One important thing to note about SPARTA 1 is currently how we locate where the swimmer is in the pool is we have to develop at the beginning of each competition a lane rope calibration file, which is the bane of every biomechanist in swimming's life, because what we have to do is count every single individual buoy along the 50 metres to work out exactly where the position is of the swimmer. So that was a high requirement of SPARTA 2, is to automate that process and get rid of the lane rope calibration. But it was basically, with where technology was at, our only way of knowing exactly where in the pool the swimmer was. Yeah, so as you start to analyse a race here, this grey strip down the bottom here, your annotations will start to appear and it will start to form an info picture down the bottom of what a race looks like. So that's basically there to provide the sports scientists with a bit of immediate feedback as to whether they've made any errors in the analysis that they're doing. So what do we learn, or what do we know from SPARTA 1 is, that our coaches have an extreme appetite for the data. They want the data, but they want it now. If they could get it live, they would get it live. One of our big pressure points for us as a sports scientist on swim teams is, as soon as a race is finished, we've got the coaches asking us, where's the analysis, where's the analysis, where's the video, where's the video. They want it as fast as possible because the coach will watch a race and they will see what they think they see with the naked eye, and they rely relatively heavily on that video and race analysis and the data to back up what they're actually seeing. They might think, my swimmer missed the turn, or their stroke rate was too high or too low. The data will back that up and confirm whether, yes, that is what's actually happening, what they're seeing, or no, they were within sticking to what their designated race plan was. The video at the moment with SPARTA 1, the way they digest that information is the coach will sit there with the computer or a screen, and that's what will have the race video on it, and then they'll have a piece of paper, as Paul said, a PDF with their race report. So they're sort of flicking between the two like this, moving, toggling through the video, and then looking at a race report and that's sort of how they digest that information. The environments that we're in are pretty unstable and unpredictable, and we're often not able to get into international competition environments until 2 days before the meet. So setting up networks and cameras, we don't know what that environment that we're going into is going to be like. So we have to have a pretty flexible, robust and reliable system to be able to operate in varying environments. The Olympics is probably one of the hardest environments for us, with a lot of broadcast cameras, etc. So setting up networks to move video around a pool to coaches is really difficult. And then the quality of the footage is really important to the coaches. So the coaches, obviously, as you all know, like in any sport, the coaches spend a lot of time just watching swimming, watching their swimmers go up and down. So they have a very good and very, very well-trained eye. And if the video isn't up to a certain level of quality, they find it difficult to use because they're so used to, and they're looking for really fine detail in their video of the performance of the swimmer.
So with our current system, we've got quite a lot of limitation, hence the need for a better system. But as I said before, capturing one lane only sort of tells you part of the story of what's going on in the pool. So that's something we've been able to work with, but it's certainly not optimal. In terms of resource heaviness, it's everything from equipment to actual people. So as I said, about 16 people. Some are operating cameras, one for each lane. Others are doing the actual annotation of the video. So if you can imagine a situation on the pool deck where you've got a team of sports scientists, most of them with PhDs or completing PhDs, sitting there hitting space bars and the letter B for breathe and S for stroke and that sort of thing. That's That's what we're dealing with. It's not an efficient use of resources. What we want is those people in the support sort of roles and sports science roles to be actually talking to the coaches so that they can get messages out of the information we're capturing, not physically sitting there processing it. And I've already mentioned about the equipment. So the opportunity that we had and what we think will have a really positive impact on performance once we get going with it is the AIS and swimming saw an advantage in providing some level of automation. So not only from the point of view of reducing the human intervention required, but also of, you've got benefits in terms of standardisation of what information and data is being captured. Because you can imagine if you've been sitting there for 6 to 8 hours annotating video, you might not be quite as accurate that afternoon as when you started that morning. Often the annotation's actually occurring late into the night. We've moved to a single camera, so we have one 4K camera. We do also have the ability to introduce a second panning camera, but we've got one still 4K camera, and I'll show you how that calibrates to the pool. That sits upon a pretty big tripod. That's just to get us nice and high, so we're already high up in the stands. But we need to be higher than everyone else, so we've got an unobscured view. So we've got one almighty tripod that it sits upon. And there's a heap of peripherals, so for example 3 gaming computers to run the machine learning that's required to operate the system. All of that packs up though into a much more compact, portable setup than what we previously had with our old system. So the next one's probably the biggest competitive advantage that we foresee. So for the first time we'll be capturing footage and data not just of our own athletes when they're racing, but also the competition. So the same analysis process will be applied across the pool, and over time we expect to build up a really quite exceptional database of races that we've been able to analyse through the system, and then we've got a whole heap of projects in mind for the use of that data and the video. At the moment, we'll occasionally look at a competitor, so if it's a Phelps or a Ledecky who was swimming, we would have filmed that, but we certainly haven't consistently applied that, but we will with the new system. So for the first time, comparative data, so from a reporting point of view, we can select our athlete who might be a 100-metre freestyler, and we can look and compare them and each aspect of their race, right down to the pacing strategies deployed in the race with their main competition. So you can imagine coaches are pretty excited about having some good evidence to work with there. At the moment, they study with their eye, as Jess said, but it's good to have the backup of some data, and we can look longitudinally and figure out perhaps how the Americans choose to race a relay versus how we've traditionally raced a relay. That's just one example. We've got hundreds in mind. And with one of the metrics that we're going to capture for the first time, we'll actually be able to look at pacing more so. So we can see with more precision when athletes surge, when they fall away, and all of the different pacing strategies used within a race. So it's a much more streamlined process. So we've introduced newer technology, but the idea was that we didn't want to let the technology get in the way of its practical application. So it's actually a lot more streamlined to use than the old system, and there's a lot less setup and movement around the pool involved. So that's very important because these are really crowded environments. If you can imagine, every nation's got some sort of system that they've got physically set up beside the pool. I mentioned the cameras. The actual software interface, which I'll show you a few screenshots of, it's a lot more logical and very easy to use. So I hadn't actually used the SPARTA 1 system myself, and recently had the opportunity to sit down with SPARTA 2, and it was literally so logical that you didn't need any instruction on what you were required to do to analyse a race. So I think that speaks a lot about the work the AIS have done in getting the software to a very clean, usable interface, and I'll show you that. I mentioned the machine learning, so it's going to basically automate to a large extent the annotation process that takes us so much time. There is the opportunity then to intervene, so if there's an obvious error or there's a portion of a lap of a race that the machine learning hasn't been able to deal with, we can connect the dots on that, and with a human sort of intervention we can make sure that we don't get little anomalies creeping into our data. I think I mentioned before, but Stu Morgan at La Trobe, he coordinated the machine learning side of it, and we've got a slide that I'm too afraid of, so Jess is going to run you through. I don't understand the machine learning bit, so Jess?
Probably something worth mentioning. This is our first attempt at diving into machine learning. And we've really jumped off the 10-metre platform straight into it. So I'm probably not going to explain it, but I'm going to regurgitate the very steep learning curve I've been on, working with the guys at La Trobe Uni and trying to understand the machine learning. My involvement in the project is as the end user, as the analyst. And we have some extremely smart people down at La Trobe Uni who work in their machine learning. So basically what the machine learning does is it will take the picture of the pool and it works off the pixels on the video. So it will identify, once we crop and calibrate the picture of the pool with the stationary camera, it's able to identify the head, and it looks for that in the pixels of the video. Once it's got a pixel that it believes is the head of a swimmer, it then brings that out, and that's where the confidence takes those crops and brings a confidence map. So you can't really see, but just in here there's like a whole lot of little dots. That's formed around the head. So it's just giving it a little bit more space rather than one pixel in the video to say that this is where the head is. Once it's got that confidence map, it then does a crop extraction. And then what it's doing through here, through the back end, in the second phase is trying to identify other scenarios that are going on. So it's looking for strokes, it's looking for the head coordinate. So one thing to note with our first phase of the machine learning is that it actually doesn't know what stroke it's swimming, because at the moment it can only identify the head and then it looks for strokes around the swimmer. We hope that it will get to the phase where it can identify strokes, but we did go down that phase to look at identifying different strokes, but we got into some trouble around an IM race where they swim all 4 strokes in one race, and then if there's varying paces being swum, in that same pool of that one picture, you may have people swimming all different strokes. So someone may not have finished their butterfly leg and someone else is up to their backstroke or whatever, breaststroke leg. So the machine learning at the moment isn't quite intelligent enough to understand what stroke is being swum. But we hope that it will get to that stage. What we do at the moment is we capture about close to like 500 races, and once we've got 500 races, we then feed back into the machine learning, and that's when it goes through that learning phase. So through the process of capturing all different video, we had to go to like a number of different pools, different swimmers, male swimmers, female swimmers, para swimmers. The more breadth in the video that we can get, light pools, dark pools, etc., the better. The more we can feed that through the algorithm, the machine starts to learn about how to identify and it becomes more accurate itself.
This slide just really runs you through the practical application of the setup. So you've got to have your camera, tripod, your machine learning laptops all connected up. We do still need people to check the annotations, as I said, because we need to verify the machine learning, but it's, from what we've seen, it's doing a pretty good job, so you don't need to intervene too much at all. We do rely quite heavily on a strong internet connection, and we don't always have it, so for that reason we've got workaround processes where we can do part of the task at the pool and then deal with that lack of connectivity. And really it's all about the interaction with the coach and athletes, so we hope that this process will make it a lot more interactive, a lot more data and conversation happening. So the major goal was that interaction and getting the sort of technology to enable sports scientists and coaches and athletes to make meaningful changes for the benefit of their performance. Jess mentioned that we have to deal with different sort of situations when we arrive at a meet. So these two photos demonstrate some of the vast differences that you can be met with. On the left, so we've got an indoor pool. You can see it's fairly poorly lit, dark and shadowy. And we've got a very high view down onto the pool. And you can see we're a little bit obscured there by someone waving some things around. On the right, we've got an outdoor pool, a little bit obscured at the bottom there by the marquees, but very bright, probably from a bit further distance away. So we need to try and be able to operate the system in different positions in the grandstand depending on what's available. So obviously coaches are going to make a lot of decisions off this system. So we've got a very rigorous calibration and testing process to go through very shortly actually. So we're currently designing that and making sure that it's going to prove the accuracy of the system. We do expect some difference between SPARTA 2's outputs and SPARTA 1, so we need to basically validate what that is and be sure of that before we go rolling the system out. It will allow us to build a much more usable history of our athletes' performances in a competition and compare to world's best. Because we've got a lot more metrics and race breakdown, we're not looking at just sort of lap times and result times, but we can get right down to the amount of times that it took the athlete to perform skills like a turn, for example, or we can look at still look at stroke rate, distance per stroke, but then we can actually then extend that now to continuous velocity capture, which previously we've calculated velocity as the time it takes to get between 2 points in the pool. Now there's a lot more points at which we measure and then formulate so that we can actually get pacing within the lap. So that's a huge step forward for us. Here's an example of what we currently do in SmarterBase. So this is our SPARTA 1 form in SmarterBase, and you can see down the bottom there's a table with all of the athletes' races. You can click into those and see the details of the race as well as the video. We also have alerts set up off this so that when the SPARTA system syncs with SmarterBase, the coach immediately gets sent to their email all of the information. One great thing that Fusion did for us was introduce these filters up in the grey section there. That enables us to very quickly get to the races we want to look at. So someone like Kyle, he'll have many races in the system, and that lets us very quickly pinpoint what we're trying to look at. This is the second page of the form. So that video, I've got a screenshot here, but in the actual SmarterBase system, that's downloadable, playable. You can speed it up, slow it down. Very usable. And you get a summary of the race and a nice report. That's the PDF that I spoke about earlier. So they're all the metrics that we currently capture and give to the coach. and that's also all reportable straight out of the report module in SPARTA. So I'm going to give you a quick run through of SPARTA 2. Basically, it's an online system. You log in. It asks you then, up the top left, there's some buttons there, and you go from left to right through a process to analyse the race. So on this screen, we're capturing the race metadata. So it's, when was it? What event are we looking at? And, is it a relay, for example? Then we move on to some input. At the moment, this is manually input from the race results file that we receive for that race. But it just gives us a sort of a data point to work within, or a perimeter. And then this is probably the most interesting. This is when we get to the machine learning side of things. So you can see this is our new software interface. At the moment, you're looking at, if you look at the lane with the white squiggly line, so that's tracking each of the blue dots is the stroke of the swimmer. Each time they've taken a stroke, you'll see like a white circle that's the system actually locating the athlete's head in the water. And you can see in this one, just in front of the athlete, there's a small break. So that means is, for some reason, the machine learning hasn't enabled that auto annotation. So we have a very quick intervention and just join those dots, and it knows what to do as far as adjusting all of the data. So we can do that across all of the lanes, so we end up with the machine learning applying itself to all lanes of the pool. This is... Now, I have to apologise for this video. This is an end-to-end demonstration of start to finish with SPARTA 2. And I asked the guys at the AIS, can you please send it up to me? I didn't realise how sped up it was, and I can't slow it down. So I'll sort of say ready, set, go, and then try and talk really quickly through the process.
Do you want to go back?
Okay, so logging in, pulling through the video, calibrating the pool, calibrating the lanes. That was a start signal, now the race metadata. We're coming over here, that's the machine learning happening. So that's completed.
Boom, race done.
There's the results coming in. So that's it going through a second time. That's how quick it is. But I'll let it run a bit. But you can see it's doing every lane. And of course, all of that, it's not just a visual thing, but as it's actually capturing that information automatically, that's feeding straight into our data repository. So it's a really big leap forward for us. And that's the output report at the end there. So we've got a much more detailed output for the coaches to look at and discuss. Sorry, but I don't know how to slow that down.
Yeah, I guess one thing to comment on for me as the end user, as the analyst, is the amount of time that saves us. So as Paul said, like at an international meet, generally we're trying to just analyse the 2 Australian swimmers. And to give you an idea, an international swim meet goes for 8 days. And I'd be lucky in 8 days if I'm getting 30 hours sleep across 8 days. Because we have 2 swim sessions, and then we analyse all through the lunch break, the morning session. We're often not returning to the hotel till about midnight, and then we're analysing. Sometimes in Rio we were going till about 5 o'clock in the morning to get up at 9 a.m. to go back to the pool again. So this saves us a huge amount of time, and as Paul said, being able to get all this data on our international competitors is something that will be really new for us and give us a huge competitive edge. The only other country that we know of that is doing anything even remotely close to this is Japan. They're starting to dabble in machine learning as well, but theirs is still quite equipment and people heavy. They're using, I think, 4 to 5 cameras, whereas we're able to use 1 camera. This bit that I'm about to show you now is an iPad app that was developed by a sports scientist and a coach from SASI, the South Australian Institute of Sport, and an app developer who was based in Vietnam but had worked with SASI and their beach volleyball program. And the coolest thing about this was it was a real problem solver. There was challenges for the coaches, as I said, with computer and data being in two separate forms. And yeah, they have found a way to solve that problem for coaches. So it's called the Locker. This is the front interface. On this one, I've just got 2 athletes in the locker, but you can have as many athletes as you want. You can have international athletes, etc., in your locker. The coaches to us, they've said it's a game changer. I've never seen a coach response to something like as positive to this as what they have, and they've taken to it really well. So as I said, the state of play was that they had the race report in a PDF, they had the video on their computer, they were using just their own coach's eye a lot. To compare races was a real challenge. Like if you wanted to look at 2 race videos, you'd have to extract the video and then put it into a different piece of software where you could mirror 2 videos. Split screens were challenging. Looking up the data to compare 2 races, trying to filter through an enormous database was really challenging for the coaches. That was also like the needs of the coach was just an easy, fast way to view video and data. Things that they like to look for historically in data are like past performances, personal bests, comparing to competitors, push notifications. So previously they would have to wait until we told them the analysis was done and pushed up into the cloud. Now there's push notifications, so we just sync and we don't have to go and notify the coach. That's all automated now, and an easy way to find historical video and data. So what's in the locker? This is when they open up a swimmer. So you can see there what happens. And this is just an iPad app. So the coaches all have their iPads on pool deck. They can have this wherever they go. But they would just click on a swimmer. So I've clicked on Kyle here. And you can see on the left-hand side, all this is like interactive. So they can like touch on any of these. On the left-hand side, automatically they have all their PB swims straight there. And that's all automated, like and updated. Then in the middle column, it's you can search by event or by swim meet. So you can see we've got 2019 World Championships this year in Korea. And then they're all the swims that Kyle swam at the World Championships this year. Probably one thing to mention, just about where the locker gets this information from. So SPARTA feeds its database. Its database sits in SmarterBase in what we call the AMS. And what the locker does is essentially it's a bolt-on to the SmarterBase, our database there. So it this locker app speaks to the AMS or to SpartaBase, and it's just extracting the video and the data from SmarterBase. Down here you can see, down here you've got video. If it's got a cloud, it means the video is accessible there in the cloud. They have the ability to then download that video onto their device so that if they're not in, they don't have internet connection, they're still able to view that video or race report. And this is the really cool bit for us. So like you saw those PDFs before and the video before, this is all it on one screen. So as I said, the locker is pulling those data annotations and then putting them over the top of the screen. So you can see down the bottom, we've got velocity, stroke rate, distance per stroke, time, what the race was up the top. And again, down here, it's just a different display. So the blue is the strokes. So you can see Kyle is what we would traditionally call has a loping stroke. So you can see it's like 1, 2, 1, 2, 1, 2, 1, 2. His breathing pattern is pretty good. That's the green dots, and you can see the 4 orange dots is telling me that he takes 4 kicks off the wall on a turn. As I said, this was huge for the coaches. I've never seen them so excited about anything. They gave the Tim Rawlins from SASI, the scientist that helped develop it, he got a standing ovation when he presented it, which was massive. Just the data visualization and presenting that and this really suited its audience, and that hit the nail on the head with the target audience. One of the big considerations was the environment and workflow, and that end user, again, being the coach and athlete. So being, coaches at a pool deck for a long time, they don't take their laptops with them, they just have an iPad with them. They can watch it on the bus on the way to the pool, they can watch it back in the hotel, they can get the video, the swimmer can be swimming down, they can lean down next to the swimmer whilst the swimmer's swimming down if they really wanted to, and show them something quickly from their race. So this video, no, this one's just a photo. So this one is showing exactly, this is a screenshot of what Peter Bishop, who is Kyle Chalmers' coach, often likes to do. So he's comparing, this is the same race, but the 2 top competitors, the number 1 and number 2 ranked swimmer in the race. So Kyle's at the top and Caleb is down the bottom. So immediately you can compare different metrics. On the right, you've got skills data. So you can see, for example, it's very well known that Caleb Dressel has the best start in the world at 5. He's 5'1" there, and Kyle is 5'6" up there on the start. One other really cool function that the locker does is you're actually able to tap on those skill metrics on the side. So where it says turn out, if I went and tapped on that on the screen, it would automatically take me to that point in the video. So you don't have to sort of drag through the video. If I want to have a look at the finish and tap on that, it'll automatically jump me to that part in the video. So you can see I've clicked on a swimmer here. I'm opening up. So I'm just looking at a race report here if I want. Now I want to look at the video from that race report. So as the swimmer starts to swim, you'll see the metrics start to come up. So you see you've got block time on the left of the screen there. And now we've got the velocity, stroke rate, and distance per stroke.
This is the bronze in lane 2, current world champion Emma McKeon, in great form here under 200. Emma McKeon looking great on the first 50 here. She's sticking with Kate Campbell. We usually see Kate Campbell too.
So this one with Kyle, what I've done here is I'm looking to compare Kyle to another one. So you can easily see all the swimmers down there. I'm looking for Caleb. I'll click on Caleb's race. Now you can see it's automatically highlighting who has the fastest in certain parts of the race. So you can really see really quickly where you're ahead and where you're behind. And again, this is the 2 races lining up. Then now I can go, okay, let's see what that looks like in the video. So that's the locker. The next stage for the locker for us will be to develop something that we can use like this in training. But yeah, this has been really huge for us and a huge development. And there's definitely no one in swimming in the world that has anything like this. This has been a real, massive game changer in the sport of swimming. We'd say, I think most of the other countries are probably at least 2 years behind as far as development goes in video and analysis feedback to coaches behind this.
Because we're the last session of the day, this will take 48 or so seconds, but I thought we'd finish with what happens when everything actually goes to plan, and all of this information and all of the athlete-coach interaction goes to plan. So this is the SPARTA view at 2016 in Rio for the men's 100 free final. That's us. Thank you for the opportunity to talk. Sorry we did take a touch long when I promised not to. But yeah, so Jess and I are very happy to talk to other sports and organisations as much as we possibly can, so feel free to come and have a chat. Thanks.